In this module, we will be covering math and looking at conversions of different from English to metric. Again, what we are focusing on is anything that could be volume or inches or feet or distance or length, and looking at how it compare if we need to convert it into the metric system. So the objective of this section is that you should be able to name common lengths, weights, volumes, temperature units, and in both inches and metric system, and convert them into other comparable units. It is important to know that because many times you may have a system that is, for example, temperature. It may be in Celsius, and you need to understand that if you deal with Fahrenheit all the time, knowing how to convert it, or things that is in gallons and compare it to liters. So you should be able to list and convert between common inches, pounds, and metric length units. List and convert between common inch pounds and metric weight units. List and convert between common inch pounds and metric volume units. And list and convert between common inch pounds, or English basically, to the metric system for temperature units. Units is basically a standardized quantity. In other words, feet is a unit, or temperature in Fahrenheit is a unit, or Celsius, or liters. All those are different standard units that we can use. Force is the amount of energy it takes to push or pull something or get something to move or to lift. All that is force. Mass is basically a quantity of something that is based on weight and volume together. It says here the quantity of matter presented, but matter takes up space. So in other words, volume and weight. So that means volume is the amount of space contained in a three-dimensional space. So what that means is that if you have a container like a cubic yard or cubic foot, it's three-dimensional and it takes up space. It has space inside of it. A cube is basically three-dimensional, and a cube would have three, like the length, the height, and the depth, and it's all the same length. In other words, a cubic foot is 1 foot tall, 1 foot deep, and 1 foot wide. You just look at something, different types of metric to English measurements. These metric units of measurements are seen worldwide on packaging and common places. So again, if you buy something, it would probably have it in both the English scale or measurement, but also the metric system too. So a bottle may be 2 liters. Years ago, you used to buy quarts or half gallons or gallons, but everything is rated in liters now. But it would also tell you the American volume of that liter. So a temperature, again, it could be in Celsius, which is the metric system, or Fahrenheit, which is the English system. And other measurements too. We can go through, we talked about in the last section, we looked at millimeters, centimeters, decameters, meters, and so forth, kilometers. All that is measurement in the metric system. But in the English, of course, we look at inches and feet, miles or yards. All would be English. Grams is a measurement of weight. In the English, we use ounces or pounds. But in the metric system, the weight, we look at grams. So we got a chart here that goes through many different types of things. So you can look at the metric system, and kind of went through that already, but I said there's in a meter, um, there's 100 centimeters. There's 1,000 millimeters. Micrometers, it would be even smaller as a million. A micro is a millionth of something. So we take a million micrometers to make up 1 meter. 10 decameters, um, uh, decimeters. So you can keep on going and looking at what it takes to make something. So in the metric system, is like I say, everything's based on tens. So in the kind of mentioned this already, we're talking about in the English system, we use inches, feet, yards, and miles. And you can see the conversions. So in other words, there's 12 inches in a foot. And of course, um, an inch is 1/12 of a foot. There's 3 feet in a yard, or 36 inches. And you could look at it, when you look at a mile, you could look at how many feet in a mile, 5,280 feet, or 1,760 yards, all the same distance. In a metric system, again, we talk about measurements. Again, we talk about meters. A meter is a distance, just like a yard is a distance. And you can see the length of each one of these based on its distance. Now, when we want to convert something, we need to know the measurements of each one of these. So when it comes to weight, we measure something in the English system by ounces and pounds and tons. Ounces basically take 16 ounces to make 1 pound. So an ounce is 1/16 of a pound. Now, when it comes to tons, it takes 2,000 pounds to make 1 ton. And we look at a metric system. In the metric system, we use grams. And until you get to very large size, we call it metric tons. Metric tons. And 1 metric ton is equivalent to 1,000 kilograms. 1,000 kilograms. Now, measurements, we see that this is looking at volume now. Volume. Remember, volume takes up space. So a volume could be 1 gallon, or it could be a cubic yard. As a matter of fact, a gallon is a measurement we use to measure liquid volume. However, volume, when it comes to, is cubic. In other words, a cubic foot, or a cubic yard, or a cubic inch, it takes up a certain amount of space. So 1 cubic foot is basically 12 by 12 by 12. So if I multiply 12 inches wide, 12 inches deep, and 12 inches tall, would come to 1,728 cubic inches. Cubic inches. Now, a cubic yard, remember, a yard is 3 feet. So again, if you multiply 3 times 3 times 3, so 3 times 3 feet tall times 3 feet deep is 9, times 3 feet wide is 27 cubic feet in a cubic yard, in 1 cubic yard. In the metric system, we use cubic centimeters or cubic meters. And again, it's 10 by 10 by 10. So we can look at how we can size these things up. When it comes to temperature, yes, there's Fahrenheit, there's Celsius in the metric system, but there's others too. There's also what we call Rankine and Kelvin. We don't see that very often. If you deal with science or engineering, you may see it, especially in science, we see it all the time, where they measuring things. And so in the Rankine, it is, I would say, more equivalent to the Fahrenheit scale. The Kelvin scale is more equivalent to the Celsius scale. So if we look at these, so you can see the equivalency of each one of these. So we know 32 degrees in Fahrenheit is the freezing point of water. However, in the Celsius scale, 0 is the freezing point. Now, both of these are exactly the same temperature where water freezes at. You're just using a different scale to measure it. The Celsius scale is pretty simple. Remember, in the metric system, everything is divisible by 10. So if you look at it, in the if water freezes in the Celsius scale, it freezes at 0 degrees. They divide it into a very even number. So they say, well, let us use 100 as the measurement water boils at. Really pretty simple. So just 100 marks, and we can see that the freezing point and the boiling point is pretty even. But if we look at the Fahrenheit scale, water freezes at 32 degrees and it boils at 212 degrees. So there's 180 different graduations from the freezing point to the boiling point, but in the Celsius scale, it's only 100. It made it really simple to figure out the numbers and what things work between. Now, the other two scales, Rankine and Kelvin, Rankine, basically, if I want to know what that is, I would basically add about 160 degrees to it. I'm sorry, 460 degrees. So if I added 460 degrees to 32 degrees, which is the freezing point, I would know what the Rankine freezing point is. And that's pretty much where it comes to if you round it off. And the same thing with the boiling point. If I take 212 degrees and add 460 to it, and I pretty much got what the boiling point in the Rankine scale. Now, when it comes to the Kelvin scale, again, it's 273 degrees. I just add to that to figure out what it is. So if at 0 degrees, freezing point in the Celsius scale, if I add 273 degrees to it, that's pretty much telling me in the Rankine scale, water freezes in Rankine at 273 degrees. And it boils at 373 degrees. Again, it's pretty simple when you're looking at the metric system and looking at the Celsius or Kelvin. Again, the Rankine and Kelvin scales, you're not going to see it in the normal line of your job. But if you saw something, which you probably will not, you will use these numbers to convert it. Matter of fact, you will see Kelvin up in electricity, where they, like if you look at the Kelvin for the color of a light by the temperature, it would be in the Kelvin scale. Alrighty, let's go through some questions and hopefully read your book. So when converting from a smaller metric unit to a larger one, the decimal point must move blank. When converting from a smaller metric unit to a larger one, the decimal point must move to the blank. The blank, move blank. So if you want to go to a smaller, you would move to the left. In other words, the number is getting, so going from a smaller to a larger. To make it, converting it, you slide that decimal point to the left, So it's actually getting larger. The number's getting larger. Next question. It says blank is the force that an object exerts on a surface due to its mass and the pull of Earth gravity. The blank is the force that of an object that exerts a surface due to its mass and the pull of the Earth's gravity. Now, again, when I said that when you look at mass, we're looking at two things: the amount of space it takes up in volume, but also its weight. So the answer would be that the force would be its weight. Its weight. Next question. It says a three-dimensional object whose sides are all the same length is a blank. A three-dimensional object which all the sides are all the same length is a cube. Great. Cube. On the next question, on a Fahrenheit temperature scale, the difference between the freezing and the boiling point of water is, I kind of mentioned it already, and it was on that other slide. And in your book, you should be able to have that answer. And so all you need to do, figure out what the boiling point is and what the freezing point. The boiling point is 212, the freezing point is 32. And so the difference between the two is 180. 180. Next question is, how many cubic feet are in 1 cubic yard? And if I can explain how to figure it out. Again, a cubic yard has 3 feet. So in other words, a yard has 3 feet in it. And if it's cubic, it will all be the same length, the height, the width, and the depth. So if you multiply 3 times 3 times 3, so how many cubic feet are in a 1 cubic yard? 3 times 3 times 3, the answer should come up to 27. Alrighty, this should end everything with this slide. And it's really getting into the next thing. We're going to get into a little geometry.